Okay, students, in this section we have to consider what is this accuracy, precision, then types of errors and the combination of these types of errors. And what is mean by this accuracy of a measurement? The accuracy of a measurement means while we measuring a particular physical quantity, for that particular quantity there exists an true value or an actual value, that is the exact value of that particular physical quantity. It may be length, mass, time, or any other type of physical quantity. Anyway, that particular physical quantity must have a true value or an actual value. And while we are measuring, that means different individuals are measuring that particular quantity, then in that time the measurement taken by which candidate is more close to that exact value or more close to that true value, that is known as the accurate value. So the accuracy of a measurement means in a measurement how close that measured value to the true value or the actual value, that is the accuracy of a measurement. For example, suppose students are taking a measurement. Let the measurement taken by candidate A, let it be measuring a particular mass or length or any other quantity. For example, we can consider while measuring a particular length, let 10.24 be the true value or the actual value of that length. While measuring that particular quantity, one student, let me assume that student A, while the student A measured, he got it's 10.2. Then another candidate B, while he measured that particular quantity, he obtained it is 10.3. And while measuring another one, C, it's 10.21 is obtained. And among these three measurements, 10.24 is the true value, and A measured, B measured, and C measured. Among these one, that candidate C obtained the true accurate measurement. Means which measurement is very close to the exact value or the true value, and that is the accurate measurement, and that gives the accuracy of that measurement. Okay, the next is the precision. What is mean by this precision? The precision or a precise measurement means that actually related to the resolution of the instrument which we are using for that particular measurement. In the previous example, we are measuring the length, so we are using a meter scale or a tab we are using. Then the precision of that measurement depends upon the resolution of that measuring instrument. Here we are considering it as a scale. So in particular situation, suppose the first person measuring that particular length or any other particular length using a scale, in that only the resolution is 1 centimeter. That means on that scale it is marked as only 0, 1 centimeter, 2 centimeter, 3 centimeter, in that way. That is, the resolution is only 1 centimeter. And another student, that is, let it be student B, he measured the same quantity with another instrument or another scale. In that one, the resolution is 0.1 centimeter. Then that means in that scale it is measured as the 0, 0.1, 0.2, 0.3, that type of measurements are there. And another student C, he measures the same length with another instrument with has a resolution 0.5 centimeter. That means 0, 0.5, 1, 1.5, 2, in that marking only in that scale. And while measuring these three students, while measuring the same physical quantity or a same length, different these A, B, and C obtain different values. Let the true value of that measurement be, it is an 8.214. 8.214 is the true value. And while measuring that particular quantity, the student A will obtain what? 8.214 is a true value, but that student A measured, he obtained it only 8, because in his scale it is only 0, 1, 2, 3, etc. only that marking. So he measured it as 8 centimeter. And in case of student B, his scale has a resolution of 0.1 centimeter. That is 0, 0.1, 0.2, 0.3, in that way. Then while he measures, he obtained what? He obtained it as 8.2 is obtained. 8.2 is obtained for that particular one. Then uh, another student, that student C is measuring that one. His scale has only the resolution what, 0.5 centimeter, that is 0, 0.5, 1, 1.5. That way is the marking in that scale. And while the student C measures, he obtained it what, he obtained it as an 8.5. He measured it and he obtained it as 8.5. Okay. Then among these measurements, the accurate measurement is for which one? It will be for the student A, because he obtained it as 8. The actual value is 8.214, and the second student, he obtained it as 8.2. Then third one, it's he obtained it as only 8.5. So the precision and accuracy, that's not directly related. Sometimes the more precise measurement never gives a more accurate one. That means whatever may be the number of trials taken by the student A, his scale has only resolution 0, 1, 2, that centimeters, in that order only. So whatever may be the number of trials he taken, he will be obtained the value 8 centimeter only. Then in case of that student B, his scale has a resolution 0.1 centimeter, that means 0, 0.1, 0.2, 0.3. So first trial he obtained it as 8.2 centimeter, and in second trial sometimes he may be obtained as 8.3 or 8.1. Then if we take another trial, then he will obtain sometime 8.4 or 8. In that order there will be a wide range of variations is possible with that much high resolution scale. Then in case of that student C, his scale has a resolution 0.5 centimeter, that is 0, 0.5, 0.1, 1.5, in that order. So while he take that measurement, in first measurement he obtained as 8.5, and in second measurement it is possible, and in second trial it is possible to obtain as 8 centimeter, or sometime it is possible to obtain as 9 centimeter. In that order there is also possible of variations. A 0.5 centimeters variations will be possible while taking different number of trials. But in case of the student A, how much number of trials he taken, that is no problem. In almost all the situation he obtained 8 centimeter, because his scale is only possible to resolve that much. So comparing with the true value or the actual value, the more accuracy for that student A. That's why we mentioned that the more precision, when we try to a measurement more precise way, the accuracy decreases, because there is a possibility of error increases when we are using highly precise measurement. More precise measurement never gives an accurate one. The accuracy sometimes gives with a low precise measurements. That's only an example is mentioned here. This type of different situations we can, that is, the precision means that increases the resolution. That means the small sections are increasing in that measuring instrument. Next we have to consider the error. What is meant by this error? In any measurement, while we measured a particular physical quantity, there is a possibility of variation from the true value or variation from the actual value. That is the error. That variation is known as the error. And the measuring errors are broadly classified into two categories, that is the systematic error and random error. Systematic error and random error. The systematic error means that is an error erased either in positive direction or in negative direction. That means from the actual value a slight increase or a slight decrease happens. Only in one direction it happens. Okay. Then this random error means that is an error erased in randomly. That means unknowingly the random fluctuations happens in the particular experiment conducting environment situation. Suppose the experiment conduction means here the measuring is the experiment. Okay, while measuring that one, unknowingly there will be a fluctuations in the environmental condition. For example, the pressure variation, then temperature variation, and also some mechanical vibrations arises. These particular changes in that environment condition also create certain errors in a measurement. Okay. Also in some situation when we are conducting the experiments with electricity, there is a variation of voltage, fluctuation of voltage arises. These are comes under that random errors. Okay. In that random errors and systematic errors, that is a broad classification of this error. The systematic error is again divided into three categories. One is the zero error, Then another one is the improper experiment technique or procedure. Then third one is personal error. That is the three classification of this systematic error. And what is a zero error? The zero error means that arises due to the improper devices or that instrument. Suppose there will be, while measuring a length or any other quantity, there will be an initial error in that device. Suppose if you are using a voltmeter or ammeter or any other device, then initially there will be a reading is, that is, the needle of that particular device is not in the zero. There will be an initial reading in that one. That comes under what? The instrumental, or that instrumental, improper instrumental error comes. Okay. And also sometimes when we are measuring a particular length, sometimes there will be a broken edge of scale. That is, that 0 and some 1.1 centimeter or 0.2 centimeter is broken away. Then while using that particular instrument also there are certain errors. Okay. And the second one is improper procedure or techniques. That means the procedure or techniques while you are measuring a particular quantity, the improper of that technique or procedure, that also creates certain errors. For example, if you are measuring the temperature, then that should be properly immersed in that or contained in that particular system whose temperature we are measuring. If it is interactive with the external environment, that is an error in that procedure, improper procedure or technique of that measurement. Okay. And the third one is personal error. Personal error means that depends upon the experimentator. Suppose the line of observation or the handling of these particular devices, that things comes under certain personal errors. While using certain devices or in observing particular readings, there will be a slight error in that observing angle or the line of observation. That also creates certain errors in that particular measurement. That comes under the personal error. Then the random error, we already mentioned that is an unknowingly happening fluctuations in the environmental conditions such as pressure variation, temperature variation, then mechanical vibrations or voltage fluctuations, etc. Least count error is another error. The least count means it is the minimum value that can be measured with the help of that particular device. For a different physical quantities, different devices or instruments we are using, and each and every instrument has a particular least count. That means the minimum value of that particular quantity which can be measured with that particular instrument. That is the least count of that particular devices. And different devices has the different least count. So that least count also creates certain errors in a measuring situations. Okay. Then other than the systematic and random errors, we have to consider the next another types of errors are the absolute error, then relative error and percentage error. What is this absolute error, relative error and percentage error? Suppose we are measuring a particular physical quantity. Then in order to obtain the exact value, we have to take that measurement in different trials. That means if we are measuring a length of a particular object, we have to, for the confirmation, we have to take it as 4 or 5 trials. Okay. And while taking these particular number of trials, there will be slight variation in each measurement. Then the absolute error means the variation or the variation of individual measurement from the actual value or the true value. If there is no true value, then the number of trials which we are taken and the average value, the arithmetic mean of that trialed values are considered as the true value. Okay. Suppose in measuring a particular mass of an object, we take 5 trials. Then the true value of that mass is not given. Then the arithmetic mean of that 5 trials we are taken as what? The true value of that particular measurement. Okay. Then the variation of this individual measurement from the true value, or here the true value is taken as what? The arithmetic mean of that individual values. And that variation, that deviation is known as what? Absolute error. And normally the absolute error is represented as delta. Suppose the individual trials which we are taken as A1, A2, A3, etc. up to AN. here 5 trials are taken, then it is becomes A5. Okay. Then the absolute error means the absolute error, that is delta A, is represented. The delta A is the variation of that individual measurement from the true value. So delta A is equal to what? It's A minus A mean. The mean value means the arithmetic mean value or the true value. Okay. For so each measurements or each trial values, we have to consider the absolute error. So let it be delta A1, delta A2, delta A3, etc. up to delta AN is the absolute errors of individual measurement. So delta A1 equal to what? It is A1 minus A mean value. Okay. It is the absolute it is the absolute error. So the difference we have to consider. Okay. Then after finding out this absolute error, we can consider the arithmetic mean of this absolute error. That is, the arithmetic mean of this absolute error is known as mean absolute error. That is, after finding the each absolute error, we have to consider the arithmetic mean, and that is known as the mean absolute error. Okay. And the relative error of a measurement means it is a ratio between the absolute value and the mean absolute value. The absolute value or the arithmetic mean value we are considered, and the arithmetic mean of absolute error is also find out. That is delta A mean value is find out, and also A mean value is also find out. Okay. And the ratio between these A mean and the delta A mean is known as what? Relative error. Okay. Then percentage error means, the percentage error means whenever we express this relative error in percentage, then that is a percentage error. That means the percentage error is, that is a ratio between mean value and the delta A mean value, and that ratio into 100%, that gives what? The percentage error of that particular measurement. Okay. Then next we have to consider the combination of errors. That means in a particular situations, the in order to obtain a new physical quantity, or in order to obtain a particular derived quantity, we have to add or multiply or subtract or divide certain fundamental quantities. In that situation, each measurement has a particular error associated with that one, and what will be the total error in the combination, that means in the resultant value. Just for a simple example, suppose we want to find the area of that area of a particular surface. Then in order to find the area, we have to measure the length and breadth of that particular object. While measuring the length, there will be an error, and while measuring the breadth, there will be an error. And what will be the total error in that area, the new derived quantity area? So about that one, that means what change happens, or how we can find the total error in a resultant value. For that one, certain conditions or certain rules are there. Mainly we have to consider the 3 conditions or the 3 rules. The first one is when we add or subtract more than one physical quantities, what will be the error? And the second situation, when we have to multiply or divide, that means the multiplication and quotient situation, what will be the error in a resultant quantity? And the third situation is, in certain situations, the new physical quantities will be expressed as the kth power of another fundamental quantity. That means another particular quantity and its power raised to 2, raised to 3, raised to 4, that format arises. In these 3 situations are mainly we are considering what will be the resultant error we can say. Okay. And come to the first situation, that means when we add or subtract more than 2 physical quantities. While adding or subtracting more than one physical quantity, the resultant relative error, while we are adding more than 2 physical quantities or subtracting more than 2 physical quantities, what will be the resultant error in the resultant quantity? And in that particular situation, when we add or subtract 2 physical quantities, the total absolute error will be the sum of absolute errors of the individual quantities. For example, we have considered two physical quantities A and B. And in that quantity A, there will be an error. We can represent it as A plus or minus delta A. There will be a slight variation. Sometimes it can be greater than the true value or less than the true value. That's why the plus and plus or minus comes. Okay, plus or minus delta A. Then in that physical quantity B also there will be a slight error. B can be expressed as B plus or minus delta B. And we have to find the new derived quantity. There is another quantity, that is Z we can represent. And that Z is also what? Z plus or minus delta Z. That means in the total quantity also there exists a resultant error. Then in this situation, that resultant error delta Z will be the sum of delta A and a delta B. That is the rule. Okay. While adding or subtract, in the subtraction also the same situation. When we have to find a Z as a new quantity as A minus B or B minus A, and in that situation also the resultant error delta Z be the sum of relative errors, the sum of absolute errors of individual quantities. That is delta Z equal to delta A plus delta B. That is, in any situation where we are adding two physical quantities or subtracting two physical quantities, the resultant absolute error will be the sum of absolute errors of individual quantities. Okay. In the next situation, when we are considering the multiplication and quotient of two physical quantities. And in this situation, when we are multiply or divide any two physical quantity in order to obtain a new quantity, the total relative error is equal to the sum of relative errors of the individual measurement. Here the same situation, two physical quantities A and B. Then A can be expressed as A plus or minus delta A, and B can be expressed as B plus or minus B. Then the new quantity is Z. Then Z is the Z plus or minus delta Z. But delta Z is the error in that particular resultant quantity. Then in this particular situation, when we are multiplying this one, that means Z equal to A into B or Z equal to A by B. And in that situation, the delta Z by Z, that is the total relative error. Okay. And that total relative error is the sum of relative errors of individual. That is delta A by A and delta B by B. Okay. Delta Z by Z is equal to delta A by A plus delta B by B. And that is in the situation when we multiply or divide any two physical quantity, the total relative error is the sum of relative errors of individual quantities. Okay. And the third situation, when we are considering the power of a particular physical quantity. Then suppose a new physical quantity is the kth power of a particular physical quantity. Then let us consider that Z is a new physical quantity and A is an individual quantity. And Z is equal to A raised to K. That is in a simple situation when we are finding the volume, what is it is L cube, length cube third power of length. Okay. Then here the K value becomes 3. Okay. And in that particular situation, when the new physical quantity is expressed as the power of any other one, then the total relative error in the resultant quantity is the K times relative error of the individual measurement. K times relative error of the individual measurement. Okay. That's about the accuracy, precision, then certain errors and the combination of these particular errors.